Good morning, all of you. Today we will discuss a very important practical with full demonstration how, at first of all, myself, Dr. Anil Kumar, HOD PG Department of Chemistry, Sahibganj College, Sahibganj, and this is my YouTube channel, that is Hot Spot Chemistry by Dr. Anil Kumar. In this channel, you will near about 106 chemistry video will be there. Chemistry video will be there of different topics which will be helpful for UGA students, PGA students, NEET, medical, engineering and other competitive exams. So all chemistry faculties are directed to must go through this YouTube channel, that is Hot Spot Chemistry by Dr. Anil Kumar. Now the practical topic is estimation of copper to ions using sodium thiosulphate solution iodometrically. This practical is very important for UGPG students. So what are the theory, what are the apparatus, what are the reagents, what are the chemicals required for this experiment? We will go on continuously. Now, what is the aim of the experiment? The aim of the experiment is estimation of copper to ions using sodium thiosulphate solution iodometrically. This is the main aim of the experiment. What are the different procedures? What are the theory behind it? We will go on. Now, what is the theory behind it? The estimation of copper is based on the fact that when excess of potassium iodide, this is potassium iodide is added to a solution of cupric salt, this potassium iodide is quantitatively oxidized to liberate iodine. The amount of iodine liberated is equivalent to the cupric ion in the solution, which is determined by titrating with a standard sodium thiosulphate solution. This is the theory behind this experiment. Now, proceed. What are the reactions behind this theory? This is 2CuSO4 plus Ki. It will give 2Cu(I2) plus 2K2SO4. This is unstable. This Cu(I2) will give you Cu2I2 plus I2. Now, this I2 plus 2Na2S2O3, it will give Na2S4O6 plus 2Na. That is, I2 is equivalent to 2Na2S2O3, that is 2CuSO4. Again, Na2S2O3 is equivalent to CuSO4, is equivalent to CuSO4, 5 water is equal to Cu. Now, since 1000 ml normal Na2S2O3 solution is equal to 63.57 gram of copper, therefore 1 ml normal Na2S2O3 solution is equal to 0.06357 gram of copper. Now, further, what are the apparatus or required for starting this experiment? At first we have to take the beaker, second is the conical flask, third is the measuring cylinder, fourth is the watch glass, fifth is the weighing scale meter, another is pipette, another is a test tube, that is dropper for giving drop by drop some starch solution. This is a conical flask and this is a burette for titrating the present experiment. Now, what are the chemicals? What are the chemicals we have to require for performing the experiment? That is, number one is copper sulphate. and you will say the color of the copper sulfate is light blue. Another is potassium iodide, that is Ki solid, and another is sodium thiosulfate solution, that is 2Na2H2O3, and this is a distilled water. And another is bench sulfuric acid, H2SO4, bench ammonium hydroxide, that is NH4OH, then acetic acid, CH3COH, that is indicatedly freshly prepared starch. This is very important, otherwise experiment will be not performed. Is it clear? Now, what are the procedure? How will you carry on the experiment? At first of all, we have to weigh out accurately 3.0 gram of copper sulfate crystals on a white glass. Transfer the weighed crystals carefully into a 250 ml of measuring flask with the help of a conical funnel. Wash both sides of the white glass and also the funnel. Remove the funnel and more distilled water is added into the measuring flask. Shake thoroughly to dissolve the crystals. Then add 5 ml of bench sulfuric acid and mark the volume up to the mark with distilled water. And then we have to shake well. This is the continuous process. The second method is pipette out 25 ml of copper sulfate solution in a conical flask. Glass stopper, add a few drops of bench ammonium hydroxide until a faint permanent precipitate is formed. Re-dissolve the precipitate in acetic acid. Add 3 grams of potassium iodide in a conical flask. Cover the mouth and keep into the conical flask in dark for 5 minutes. Remember, the whole solution should be kept into the dark medium, that is for 5 to 10 minutes. Then titrate with the standard sodium thiosulfate solution already taken in a burette to a pale yellow. Remember, this will be pale yellow or maybe a straw color. Or maybe a straw color. Add 2 ml. This is 2 ml. Add 2 ml of freshly prepared starch solution. Remember, we have to prepare the starch solution freshly prepared. And continue the titration till the blue color. Remember, blue color disappears permanent to colorless. Take at least 2 to 5 concurrent readings, or you may take 4 to 5 readings. 4 to 5 readings for perfect data. Now, good morning. Today we will discuss a very beautiful experiment, that is estimation of copper 2 ions using sodium thios solution iodometrically. In this experiment, what are the reagent, glassware, apparatus is required. So beautifully we can see what are the chemicals required for this experiment. As first of all, so we have to choose copper sulfate. Here we see this is a copper sulfate, that is N/10 solution, number 1. Number 2 is ammonium hydroxide, that is NH4OH. Number 3 is acetic acid, this one acetic acid, and potassium iodide, that is Ki. Then sulfuric acid, this is bench sulfuric acid, you may see. And then this is a starch solution, this is specially prepared starch solution. And last one is this one is sodium thiosulfate. This is sodium thiosulfate. You have seen this is sodium thiosulfate. And we have to take this pipette. This is pipette, and this is a burette. This is for titration purposes, and this is a stand, and these are the measuring cylinders. This is a conical flask. These are the conical flask, and this is a funnel, and this is a dropper, and this is the test tube holder. These are the generally glasswares required for titrating the copper, estimation of copper ions using sodium thiosulfate solution iodometrically. Then what are the procedures, how the experiment will be performed? It is beautifully we can see how the experiment will go on. one. For the estimation of copper using thiosulfate solution iodometrically, at first of all we have to take the 25 ml of copper sulfate by pipette, and whatever the 25 ml, it is transferred into the, this is transferred into the conical flask. Just to leave the, whatever be the solution in the pipette is transferred into the conical flask, that is 25 ml of copper sulfate solution of n by 10. Is it clear? Then now it is okay. Now 25 cc total ml of copper sulfate is transferred into the conical flask. Just to keep on. Then add 5 to 10 drops of ammonium hydroxide to it. Just to take start. Just to take 5 to 10 drops of ammonium hydroxide in the conical flask, and just you stir it, shake it 5 to 10 drops. Is it okay? Then we have to drop again 5 to 10 drops of acetic acid. You take this as this one is acetic acid. You drop 5 to 10 drops of acetic acid, drop by drop, and you shake it. Okay. Then we have to take 1 gram of solid potassium iodide. This is in the liquid form. Just you take this one. How much you have to take? Half test tube. Just you take half test tube of potassium iodide. Just you add it. Half test tube of potassium iodide. This is potassium iodide. Potassium iodide. You just add it in potassium iodide solution. Just use still. Now see the straw color. This is a straw color, pale yellow color straw color. Then again we have to add 5 ml of bench sulfuric acid. Just you add 5 ml of bench sulfuric acid. This is how much? 5 ml. Just you add 5 ml bench sulfuric acid. Here it is 5 ml. 5 ml. You just add it 5 ml. Just you add it 5 ml. 5 ml. See, this is 5 ml. I hope more or less. This is 5 ml. This is 5 ml. Just you add it 5 ml. Bench sulfuric acid. Okay, just to shake it. And thus the whole solution, this whole solution will be kept into a dark for 5 to 10 minutes. You have to just take it in dark. Dark dark. It will be kept for dark shadow. Come for this is cupboard. This is for dark. 5 to 10 minutes. Just see. It is kept for dark. 5 to 10 minutes. Now, for the titration purpose, we take the sodium thiosulfate solution, which will be kept into the beaker, burette in this way. Just you fill the data, we fill the sodium thiosulfate in the burette up to, it will be marked as 0, up to 0. 0, 0, 0, no. Little bit. No, it is not 0. If there is excess amount, then we will, this is just you will drop by drop, we make it at 0. 0, 0. Okay. Now it is 0. Now it is 0. Just you see the value is 0. Is it clear? Now wait. We take the freshly prepared starch solution. We are just try to prepare freshly prepared starch solution for the present experiment, which is going on seriously. Now the solution which is kept in dark room, that is dark side. Now we'll take after 5 to 10 minutes. We have just take this solution from the dark. This is just you see the reaction is going on. This is a just you take. Chalo, carry on. ठीक से है, ठीक से जो. Now we have to go there. Now see the color will change. Now we have to add drop by drop. 2 ml freshly prepared starch solution. Just you add 2 ml starch solution, freshly prepared starch solution. Just you add it drop by drop. 2 ml. Just you add 2 ml. No problem. You add it. Roughly 2 ml of starch solution, freshly prepared. Then we see the slightly blue color will appear. Just we add it. 2 ml. This is what beautiful blue color. Now this is the blue color you see. Now it will be titrated. No, now start titration. You add all. Just you see, these are the blue color. Blue color. This is the blue color. Now it will be titrated. Drop by drop. Drop by drop. We will see the color. Drop by drop. Drop by drop. Let it colorless. 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 Now we have to wait. At what time? At what value the solution become colorless? Just you see. We have to add drop by drop and see when the color changes. Data is coming, na? Is it good? At what value, roughly value? Little bit, little bit, little bit. See the value? 15.5. This is now the solution becomes colorless. Okay. Now you take the data. The data. What is the value of data? This. How much? This is you see the data. This is 18.1. Is it correct? Huh. In this way, in this way, Sumit ko bolo. In this way, we have to perform this experiment 3 or 4 times to get the accurate data, so that the experiment will be completely okay. And we have to, by taking all the data, we have to calculate we have to prepare a table, and further calculation is done, and thus the estimation of sodium thiosulfate, estimation of copper using sodium thiosulfate solution iodometrically will be done by calculating the different data and putting the different values in the given equation, and we get the final result. Is it okay? Yes, sir. Now you have to perform the different experiments. Just to see, you take all the photos. Come, sister. Now after titrating, we have got this white colorless solution, and we have to repeat this experiment thrice or 4 times, so that we get the good result, and we will put all the data and we will calculate the experiment fully. This is all about iodometric titration. And one of my friend, Dr. Dhruv Jyoti Singh, head of the department, just come to meet me, and he has seen the beautiful experiment, that is estimation of copper ions using sodium thiosulfate solution. And this is the answer. This is a solution, and we have to calculate the different calculation part, and he has enjoyed, and he had till something
भविष्य में भी अनिलों से यह आग्रह है कि इसी तरह का पठन पाठन प्रैक्टिकल के रूप में करके बच्चे को समझा दीजिए।
अभी हाँ सर, ये तो हम लोग का प्रयास है और हम लोग चाहते हैं कि यूजी पीजी के जितने भी बच्चे हैं, जो भी हमारे पास उचित संसाधन है, उचित संसाधन के अंतर्गत हम बच्चों को मोटिवेट भी करते हैं और बच्चों को चाहते हैं कि केमिस्ट्री का सी सीखे और अपने हाथ से काम को करके जाए। और इस तरह का प्रैक्टिकल वीडियो हम लोगों ने बहुत सारा प्रैक्टिकल वीडियो किया है और हम लोगों ने अपना एक केमिस्ट्री, जो गरीब बच्चे हैं उसके लिए हम लोगों ने यूट्यूब चैनल बनाया है, जिस चैनल का नाम है हॉट स्पॉट केमिस्ट्री बाय डॉक्टर अनिल कुमार। इसमें इंटर से लेके पीजी तक के बच्चों को केमिस्ट्री के महत्वपूर्ण टॉपिक्स पर चर्चा किया गया है। बच्चे, सुदूर गांव के बच्चे जिनके पास संसाधन की कमी है, वो इस ट्यूब के माध्यम से बच्चे इस प्रैक्टिकल को देख सकते हैं, थ्योरी क्लास को देखकर लाभान्वित हो सकते हैं और आने वाले एग्जाम में वो अच्छे नंबर से अच्छे नंबर को प्राप्त भी कर सकते हैं। और ये बहुत सहायक महाविद्यालय के लिए बहुत गर्व की बात है। इसमें हमारे प्राचार्य महोदय राहुल कुमार संतोष का बहुत ही योगदान है और आप सभी बच्चे इस कार्य को उत्साहित रूप से करते हैं। What we have seen in the practical, we have collected so many data. The data, that is, this is table one table. What are the data we have? Data we have collected, they are performed, or performed. So that is the observation, that is 1, 2, 3, 4, and volume of CaSO per solution taken, that is 25 ml. Each time we have chosen 25 ml. Burette reading ml in sodium thiosulphate, that is initial value is 0. After titrating, the value comes to 18.1 and the difference is 18.1. Again we have titrated, that volume is taken 18.1. Again finally titrated till the colorless happens, the value goes to 13.5.9 and the difference is 17.7. Again we have washed all the solution through and freshly taken all the things as discussed in the procedure. Again the value is, we have taken at initial 0 and the value goes to 17.6 and the difference is 17.6. And again we have thrown all the solutions and washed all the things, and as discussed in the procedure, we will follow all the procedures. Again titration starts and the volume of CuSO4 solution taken by pipette is 25 ml, and adding all the solutions, we got the data 17.6 and the final data is 13.6 and the initial value 17.7, and the concurrent reading we have got 17.77, and the strength of the sodium thiosulphate solution, that is n by 10, that is the factor is 1.07. we use the data for calculation, and how the calculation goes on, just to carry on. And the indicator used is for the present case is starch, that is freshly prepared. Remember this thing. We will see in the practical video how starch is freshly prepared in our lab. All the things will be clear in the practical video earlier. Now what this is the calculation part and this is the important part. What we have got the data, we concluded in this calculative part, that is 25 ml of CuSO4 solution is equivalent to 17.7 ml of, that is factor is 1.07 of Na2H2SO solution. Therefore 250 ml CuSO4 solution is equal to 17.77 into 1.07 into 250 divided by 225 into 10 ml of Na2H2SO solution. That is equivalent to 177 into 107 by 100 into 100 ml of Na2SO4, so Na2H2O solution. That is equal to 190139 divided by 1000 ml of Na2H2SO solution. That is equal to 99.01 ml of Na2H2SO solution. As we know that 1 ml of normal Na2SO3 solution is equivalent to 0.06357 of copper. Therefore, the value 19.01 ml of Na2SO3 solution is equivalent to 0.06357 into 19.01 gram of Cu. That is equivalent to 1.20846 gram of Cu. Therefore, it is 3 gram of CO. So for contains 1.20846 gram of CO. Therefore, 100 gram of copper sulfate solution contains 1.20846 into 100 divided upon 3 into 1000000 gram of CO. Further calculation we get that is 40.28 gram of CO. This is the estimation of copper 2 ions in sodium thiosulfate, that is 14.28 gram of Cu. Alright. This is all about the experiment. So this video was done and created by myself, Dr. Anil Kumar, HOD PG Department of Chemistry, Sahibganj College, Sahibganj, and with our chemistry students like Rishabh Raj, Abhishek, Sartab, Happy, Devrat, AP, and so many UG PG students. So or next day new video in chemistry, or it may be theory, it may be practical. So best of luck for the coming exam. Hope you will, by seeing all the experiment, all the theory, whatever discussed in this video, you will use it in your practical exam, so that you can get the maximum marks in the coming exam and in further also in different competitive exam. Thank you. Best of luck. Best of luck.